Good morning, pre-calculus. Today's lesson is on ellipses. Ellipses are probably what you have commonly referred to as ovals over your mathematical career. You can see up here, if you take a cone, which is where the word conics is derived from. Conic is a cutting of a cone, and so you see here, if we take a plane and we cut it through the cone, it makes an oval shaped object through the cone, and so that's what we call an ellipse. This diagram can be found in your lesson resources, so if you would like to cut that out and put it into your notebook, that would be a really good idea. What I'm going to do first here is just show you the slides where the information is given to you and give you an opportunity to write this stuff down in your notebook. So as I move the slide forward, feel free to pause your video and copy down those notes on ellipses, and then I will forward it one more time. So there are 3 slides here. The one that you're looking at right now, and 2 more pages behind this for you to copy down before we start getting into how to graph the ellipse. So this is page 1. Here is page 2. Feel free to pause the video at this time. And now I'm going to forward to page 3. Feel free to pause your video at this time and copy this down. And when we come back, we will talk about it and begin graphing. Okay, so this is a typical equation for an ellipse. And so one of the things that you're going to want to pay attention to when you are graphing an ellipse is which number on the bottom is bigger. And so this number here on the bottom, this 25, is going to be your a squared, and the 4 is going to be your b squared. So as you were writing down your notes earlier, you'll see that there's an a squared and a b squared, and they will flip-flop. So it is possible that a squared could be on this side, b squared is on this side, but what you'll find is that a squared is always going to be your bigger variable. It doesn't mean that it'll always be under the first fraction, okay? And so what a does is it tells you how many places to move, or what's under the x is what tells you to move left or right from the center, and then the b, which is the variable that's underneath the y, will tell you how to move up and down from the center. The center was created just like you create a center for a circle. It was the h and k. Please remember to change those signs as you go to plot that value. The major axis is always going to be the larger distance between the vertices, and the minor axis is going to be the shorter version between the co-vertices. The focal points are going to be a little bit more complicated, so we'll get back to the focal points as we get into graphing. Okay, so let's take a look at this. It says graph and label the important features, which would be the center, the vertices, and the foci. We will also label the co-vertices as well. All right, so let's see how I'm doing today with the class pad. All right, so the first thing we want to do, all right, let's get a pen, is we want to come up with a center value. All right, and so we see here we have a -5 and we have nothing. So we're going to change that value of 5, make it a +5. And we had nothing behind the y, so our center is 5, 0. So let's see, 1, 2, 3, 4, 5. Okay, that is our center. I'll do the best I can to get a little C right there. Okay, that's our center point. From there, we're going to determine what our vertices, what our vertices are going to be. I am going to redo that for you. All right, so we talked about how the number underneath the X is going to tell us how far to go left and right. So we're actually going to square root that number. So we're going to say, all right, what is the square root of 25? And so that 5 is going to tell us to go right and left 5. 1, 2, 3, 4, 5. Oh, there we go. 5, come on. And then left. We've got to go left from the center as well. So 1, 2, 3, 4, back to the origin. Right there. And these, okay, so we'll leave those 2 points there for a moment, and then we're going to come up and we're going to look at this value, the 4. So we'll take the square root of the 4, and we're going to get 2. Since that is underneath the y, we're going to go up and down 2 units. 1, 2. This is very similar to a circle that you would have done yesterday. The difference between an ellipse and a circle is that the circle has equidistant from the center all the way around, and the ellipse will not. So we have 4 points that kind of surround this center, 2 of which are vertices, 2 of which are co-vertices. So let's see. The co-vertices, let's see, back up. Back up. So the minor axis, which is the shorter one, is what houses the co-vertices, and the major axis, which is the longer one, is what houses the vertices. So as we move back over here, I think I still have a red pen. So come on, pen. So right here we have the co-vertices, and this is going to be vertices. So as we come over here to our vertices, those ordered pairs of the vertices should be 10, 0, 10, 0, and the origin, which was 0, 0. So 0, 0. My apologies with the class pad. I am just learning how to use this, so please bear with me. The co-vertices, which I will put in red, are, looks like 5, 2 and 5, -2. So 5, 2 and 5, -2. Oops, come on, 2, 2. All right, so make sure you get parentheses around those. All right, come on. All right, and then we have to do the focal points. All right, so let me go ahead before we do the focal points. Let's attempt the best I can to draw this ellipse. So we basically are going to do the best we can to connect the 4 vertices and co-vertices. So again, I apologize for my drawing. I'll get better as time goes by. All right, so now we get to go do the focal points. All right, so let's back up and talk about the focal points. Focal point is a calculated value. Okay, so what you'll see is right here, C tells you how many places to move up and down from the center. Okay, now it could be left or right. This is going to be along the major axis. Okay, so remember the major axis is the longer axis. So we may not be going up and down, we might be going left or right. So it just depends on which one our major axis is. So when you look at our ellipse, you'll see that our major axis is the longer one. Our longer one is here. So we're going to move left to right from the center. That's not where I wanted to be. So we're going to use one of these 2, okay? The larger denominator is going to be first. So that's going to be the 25. So we're going to come over here. Oh my God, I'm getting tangled. I am all kind of tangled. All right, so do this down towards the bottom. Do the calculating. Okay. So over here, we'll have an equation that is c squared equals, now I call these my CAB equations, c squared minus a squared equals, I'm sorry, c squared equals a squared minus b squared. And so you can see that it spells CAB, C-A-B. Now, it's the larger denominator first. So our larger denominator is 25. and our smaller denominator is 4. So that puts us at 25 minus 4 is 21. I'm going to go over to our calculator, and I'm going to take the actual square root of 21. I want to know what that decimal value is. So it's 4.6 essentially. So we did c squared equaled 21. So c was 4.6. So that 4.6 becomes the distance. Okay, let's see. Let's go back. Foci, okay, 2 points along the major axis. C tells you how far to move. And so we're going to add C to the center. So we're going left and right from the center. All right, so we're going to go 4.6, which is 1, 2, 3, 4. And it's going to be in there. I can't quite get it all the way there. It's going to be right in there. So hopefully you see that it's blue. That's the focal point. That's one focal point. This is the other focal point. All right. So we have our center, we have our vertex, and we have our focal points all labeled within our drawing. And so what last thing I need to do is come over here and write down the ordered pairs for the focal points. So our focal points, there's 2 of them. All right, so this first one right here, remember that it came over 4.6. So that's going to put us at 0.4, comma 0. Ooh, that didn't work out very well. Let's try it again. 0.4, comma 0. That's the first focal point. And this focal point that's way over here is going to be 9.6. 9.6, comma 0. Okay? And that is how we graph an ellipse. All right, guys, so I'm going to show you another one real quick. I'm doing this a little bit different, using a different way to record it, or a different way to write it. All right, so this has a center at 1, -2. Okay, and those come from here and here. So we have 1, -2, so 1, -2 is right there. So that's going to be the center of the ellipse. Now we're going to square root the 2 denominators so that we can find the vertices and the co-vertices. So this one is going to be left and right. This one is going to be up and down. So we're going to go square root of 4 is 2. So we're going to go 2 units to the right of the center and 2 units to the left of the center. And then you'll start to notice that this side right here is going to be where your co-vertices are, and this is where your vertices are going to be because of the longer axis. So you take the 25 square root, 1, 2, 3, 4, 5 right there. 1, 2, 3, 4, oops, 1, 2, 3, 4, 5 right there. We have our more vertically tall ellipse on this one. So your co-vertices are out here to the left and to the right, where the vertices are up here at the top and the bottom of the ellipse. So I'm going to just erase some of this green stuff in the middle here. I just kind of got in the way. All right, so let's do this. Let's write down what our center was. We said that that was 1, -2. Our vertices are going to be 1, 3, and 1, 2, 3, 4, 5, -6. The co-vertices, we didn't list this on the last one, is -1, -2. And I'm going to move this out to the right. We've got 1, 2, 3. So 3, -2. I'm going to rewrite that. Three, -2. So that's the vertices, co-vertices, and the center for that ellipse. Let's scroll down, and we'll start working on the focus. Sorry, I didn't go down. I've got to extend the page. Okay, so to do our focal points, we use the CAB equation. The a squared is always the larger denominator. It's 25 minus 4. So that's going to be the same 21 that we came up with in the last problem. So using the same math, we'll have 4.6 as our C. So that time we will take our C and go 4.6 up, which is going to be up in here. It's not going to show it to you very accurately, but these are where the focal points are. And so if we write down the focal points, we will be this, the top one will be at 1 and 2.6. The bottom one will be at 1 and -1, -2, -3, -4, -5.6. So that is the second ellipse. So problem number 3 is a completing the square problem to get it into standard form so that we can graph it. Now, I'm not going to actually graph this one. We're just going to put it into standard form. And during the live session, if you want your teacher to graph it with you or explain how to do something, then by all means, please ask him to do that. So what we want to do is we want to gather our like variables together. So here, and hopefully you did this when you were doing circles and completing in square for circles as well. So you'll see the red is the X variable material and the Y is the green is the Y variable material. And then you have the constant, which is this -11, all right? So you got to find all that stuff. So what we're going to do is we're going to take these two and we're going to put them over here. We're going to take these two and we're going to put them right here. And this constant is going to move to the right-hand side of the equation. So it'll look a little bit like this. 9x squared minus 18x. And then I'm going to leave some space right there so that we can complete the square. We'll move over to the y material, 4y squared plus 16y. Again, I'm going to leave some space right there. I'm going to have the equal sign, and then I'm going to have the 11 gets added to the right-hand side of the equation. So you notice it changed from a -11 over to a +11 right there. All right, and this is where the completion of square technique comes in. So I'm going to concentrate solely on the red X material first, and then we'll move along into the green and we'll finish that. So here we have a leading coefficient, and that leading coefficient has to be factored out of the red material before we can complete the square. So we'll factor the 9, which is an important part of the ellipse as we get to the end of it. So you factor that out, that's x squared minus 2x. Let's keep that space right there. Okay, we got to complete the square. So the parentheses is where we're going to complete the square. So now we're focusing on this part of the problem right there. All right, so we're going to take half of the -2, and half of -2 is -1. you're going to square that number and move it up into that blank that you created. So -1 squared is 1. So you have a perfect square trinomial that is highlighted in yellow. And so what happens there is you've created a factorable trinomial that becomes x minus 1 squared, which is part of the standard form of the ellipse. As 9 has to drop down and stay in front of, let's turn that into red, and stay in front of that factor. Now, one of the important parts, this is the part that everybody forgets to do, is, the rule of algebra is what you do to one side, you got to do to the other. So what you've done is you've added this number 1, this black number 1, into the problem. But really, you haven't added 1 into the problem, you've added 9 times 1 into the problem. So over here, you end up having to add 9 to both sides. So the left-hand side's had a 9 added in, and now the right-hand side has added 9 to the problem. Okay, so the red part now is completely ready to go. So we jump into the green. Our 4 leading coefficient here got to be removed from the problem. We've got to factor that out. So we have 4 parentheses y squared plus 4y plus blank. Okay, so we have factored out the leading coefficient of the green y material. Okay, it's completed in the square now. We take half of the 4, which is 2, and turn that back into green. 2. That gets squared and pushed up into here. So 2 squared is 4. Sorry, to get rid of that. All right, and so we are ready to complete the square for this problem. So we went half of 4 is 2. 2 squared is, I lost my color. 2 squared is 4. And so now again, you have a perfect square trinomial that is highlighted in yellow, which is completely factorable. So we will bring down this y, green, y, and we have the final, we've got the k now of our circle, of our ellipse. So we'll bring this 4 right here has to stay in the problem, so the 4 stays right there. And again, remember that we added, what you think of is you've added this 4 to the problem, but in reality, you have added 4 times 4 to the problem, which is 16. I know this looks pretty messy, but the more you kind of work the problem, the more it kind of makes sense, and you'll be able to pull what you need. So here's what we have. We have this right here, and we've got to sum this material up on the right. So 11 plus 9 is 20, 20 plus 16 is 36. So let me clean this up for you. That's got to be moved down so we have more space. Move that down. No problem for later. So here's what we have. Here's where we are. We're at the purple. So I'm going to rewrite this just so we can see what we have. We have 9x minus 1 quantity squared plus, because it's an ellipse, 4y plus 2 squared equals 36. All right, so we're not done because it's not in standard form. You don't have the fractions that you need to be able to get your a squared, your b squared. Well, one of the things that hopefully you may have seen at the very beginning of today was that the standard form for an ellipse is always equal to 1. So we need to make our ellipse that we just created equal to 1. So the black equation is what we're looking at. How do we make this equation equal 1? Well, we divide by 36. And this is where I was talking about how important the 9 and the 4 were being brought back down into the equation. So we simplify these. So right here and right here will simplify and give us our final version of the equation, x minus 1 squared divided by 9 goes into 36 4 times, plus y plus 2 squared divided by 4 goes into 36 9 times, and now it finally equals 1, just like we needed it to. All right, so I'm going to do one more of those completing the square problems. A lot quicker, a lot cleaner this time. Try to explain it as I go along. So the x material, 16x squared, is the only x material in this problem. So then we go on to 65 y squared plus 130y plus, leave yourself a little blank, equals this 975 that gets moved to the right-hand side of the equation. So the 16x squared, done. All we have to do is wait to divide to get to the 16x squared. You don't have to complete the square. It's already a perfect square. So that puts us only on this green material we got to finish up. So we factor out the 65. Just the 65. Y squared plus 2y plus, leave yourself a blank, equals, and we'll leave the equals alone and just concentrate on this green material. Completing the square takes half of the 2, squares the 1, 1 squared is still 1. You didn't just add 1 to the problem, you actually added 65 times 1 to the problem, and so you are adding 65 to both sides, left side and right side. Okay, so we're back to the green. We'll finish up the perfect square trinomial. We will bring down the 65. The new technology is a little bit more sensitive. And I'm green. And we're ready to divide. Okay, we do have to add up the right-hand side, so we'll actually add that up first. So, let's see, 25 makes it 1,000. So, let's see, 975 plus 65 is 1040. 1,040. So that's what we're going to divide by. We're going to divide by 1,040. So this 16x squared is still there. Right? So we're going to take and we're going to divide by 1,040 each part of the problem. Simplify those fractions. So 1,040 divided by 16 gives us 65. Where did that go? Here we go. So we are finalizing this problem. X squared divided by 65 plus 65 into 1040 be y plus 1 squared. That should go in 16 times. Equals 1, and that is the standard form of that equation. All right, last two problems. We're going to create an equation for an ellipse based on ordered pairs that are given to you. Now, I'm a big grapher. I like to visualize what it is that I am creating. So I like the graph and the grid paper sitting there with us. So my suggestion when you go to create this equation is that you go ahead and you set up what I call like a skeleton equation. You know that the equation is supposed to look something like this right here. Okay, and then you can fill in the gaps of the numbers. So you're going to need a number here, you need a number here, you need a number in the denominator for each of those places. So what you're going to need is you're going to need a center, and you're going to need the A and the B that are your denominator. So those are the four numbers that you're going to need. You need an H value, a K value, an A and a B value. And you can get all this from plotting it on the graph. Okay, so I'm going to delete these green pound signs, these hashtags as you would call them. Okay, and we're going to go find that information. So we're going to plot, we're going to go plot these numbers right here. So 2, -2, 2 to the right, 2 down, -2, -2, 2 to the left, 2 down, 0, 3, so 0 and then up 3, 1, 2, 3, and 0, -7, 1, 2, 3, 4, 5, 6, 7. So what that does for us is you don't even actually have to graph the ellipse itself. What it does, if we connect those 4 points, it shows us everything we need. That cross section right there is your center. And so we get a center value of 0, -2. And so we can take those numbers and plug them right into the equation. Yes, you get a double negative on the y minus -2, okay? But it is not wrong if you leave it just as it is. Most of us at that point are going to want to create the +2. So plus 2 out of that. So we're halfway done writing our equation. Now all we need is our A value and our B value. The A value is the longer of the values from the center to the vertex. So here is your vertex right here. So how long is that right there? That is A. So if you count those units, 1, 2, 3, 4, 5. So we have 5 units right there. Remember that underneath the denominators are squared values. So we take the 5, square it, and you get 25. Now the question is, where does the 25 go? Does it go under the X or does it go under the Y? Well, look at what it's doing. Over here, it is a vertical distance. So vertical is always going to be your Y's. So that 25 is going to go underneath the Y squared part of the equation. So now we are counting this distance here, which is B, and you can see that that's going to be a 2. We square it because numbers that are underneath underneath the fraction bar are squared. So we take the 2, we use a 4 for the B squared value, and boom, there's the equation. Done with the problem. Okay, so you can probably see as I look at my timer, that only took 4 minutes, and I was explaining the whole thing. Okay, so let's roll down here to problem number 6, the last problem of the day, and we'll see how we can get this done pretty quick. Okay, write the equation of an ellipse with vertices there and foci. Okay, so here we have a little different problem. We don't know exactly where the co-vertices are, but that doesn't mean we can't figure this out. Okay, so we get to plot these values, and it's going to help that you label them. So 7, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. That was a vertex. We got negative 3, 2, 1, 2, 3, up 2. That is also a vertex. Now, if they are vertices, what that tells you is that this value right here is going to be the larger value. All right, so as you continue to make your skeleton equation, you guys, we already really know what our center is going to be as well, because the center is going to be halfway between those 2 points. So how far is that? Let's see. Let's make that bigger. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 units. Okay, that's 10 units. So halfway is 5, which puts our center 5 units from each vertex. So 1, 2, 3, 4, 5. That is the center right there. We already know a couple values we can put into our equation. That center is at 2, 2. So 2, 2. You can see that the skeleton equation has already changed the signs of those numbers of h and k. All right, so let's get rid of some of the stuff that we have on here. Clean this up a little bit for you. And now let's deal with why they gave us these values. So the focal points are how we're going to figure out what are the a squared and the b squared that go underneath our fractions, okay? All right, so remember that focal points are created using the c squared equals a squared minus b squared equation. So let's plot these. 6, 2 is going to be here, and negative 2, 2 is going to be there. So these are our focal points. Okay, so what do we know? We know that our a value is 1, 2, 3, 4, 5. Okay, so a, which means we can come over here and we can put 25. That's our A. What we don't know is our B, so we've got to continue to calculate. What else do we know? We know our C value. We know that our C value is 4. So C value is from the center to the focus. So if our C value is 4, we square that, we solve this equation, and it gives us the number to put underneath the y minus 2 squared. So if we subtract the negative 5 squared from both sides, so it's 16 minus 25, which should be negative 9. And if you'll notice, b is also negative, so that just wipes out both negatives in the problem, and it tells us our b squared equals 9, which is the number that we're going to put right here, 9. And that is the writing of an equation of an ellipse. Now, we're done with all the problems. Your homework will be attached in your lesson assignments in your CTLS Learn, and your teacher will make sure that you know what your assignment is. Thanks for listening, guys. Hope you guys have a great day.